misalignment. Imagine a machine setup where two shafts, meant to be aligned in a straight line, are offset from each other. This creates a scenario where the shafts are still parallel but misaligned horizontally or vertically. You might see this depicted with two cylinders or gears connected via a coupler, with the center lines of the two shafts being slightly displaced. One of the shafts is slightly higher than the other. In industrial applications, a motor is often connected to a pump using a coupling. If the shafts of the motor and the pump are not perfectly aligned but remain parallel, meaning their center lines are offset but not angled, parallel misalignment occurs. This can happen when the pump or motor is installed slightly higher or lower than the other due to uneven mounted surfaces or improper installation practices. Effect: parallel misalignment leads to excessive vibrations and can cause premature wear of bearings, seals, and couplings. Vibration analysis would show spikes at the 1x and 2x rotational speeds, whereas angular misalignment occurs when shafts are at an angle to each other instead of being aligned in a straight line. One shaft is tilted upward and the other downward. Example is a fan and motor assembly. In large HVAC systems, a motor is often used to drive a fan through a coupler. If the two shafts are installed at a slight angle to each other rather than in a straight line, angular misalignment occurs. This can happen when the motor and fan are not aligned properly during installation, where one shaft might be tilted upwards or downwards relative to the other. Another example is in a car, steering system, tie rods, and steering rack. If the tie rods are not properly aligned or wear unevenly, the angle between the steering components and the wheels can become skewed. This can also happen if there is damage to the suspension. Effect: angular misalignment in the steering system leads to poor handling, excessive tire wear, and difficulty in maintaining a straight line while driving. In both cases, misalignment causes increased wear, vibration, and noise, leading to reduced efficiency and potential equipment failure if not corrected. Alignment tools like laser alignment systems are used to avoid these issues.